Good afternoon. You are looking at a view from a balcony camera at the large International Space Station Flight Control Room at the Russian Mission Control Center in Korolyov, Russia, on the outskirts of Moscow, as Russian flight controllers are tracking the progress of a Progress 91 uncrewed cargo ship that is closing in for an automated docking to the aft port of the Zvezda Service Module at the International Space Station to conclude a 48-hour journey since its launch from the Baikonur Cosmodrome on Thursday. Good afternoon to everyone for our coverage for the Progress 91 docking. We are in mission control in Houston at the Johnson Space Center in the International Space Station Flight Control Room, continuing to keep tabs on the developments as the Progress has flown flawlessly since its launch 2 days ago, now in the final home stretch of its approach for its automated docking to the International Space Station. About an hour ago, the station was maneuvered into the proper orientation for the arrival of the Progress, which will conduct a fly-around at a range of about 400 meters away from the International Space Station. That fly-around maneuver to begin about 26 minutes from now that will precisely position the forward docking port on the Progress resupply vehicle to the docking port at the aft end of the Zvezda Service Module that was occupied previously by the Progress 89 cargo ship that undocked from the space station back on Tuesday to clear the port for the arrival of the new uncrewed resupply vehicle. This Progress that is closing in for its docking that is scheduled at 5:03 p.m. Central Time, 6:03 p.m. Eastern Time, is carrying 2.8 tons of cargo. That breaks down to 5,730 pounds of food, fuel, and supplies for the expedition's 72 crew on board. The specific breakdown of that cargo includes 2,599 pounds of hardware, food, and experiments, 2,095 pounds of fuel, 926 pounds of water, and 110 pounds of nitrogen. On board the space station, the NASA astronauts who are on board, led by Sonny Williams, the station commander, along with Nick Hague, Don Pettit, and Butch Wilmore, are asleep at this hour. Their Russian counterparts are awake, monitoring the approach of the Progress for its docking. The cosmonauts on board, Alexei Ovchinin and Ivan Wagner, are actually inside the service module at a workstation, manning a control panel called the Toru system, the telerobotically operated rendezvous system that they would use in the unlikely event a failure occurred in the home stretch of this approach to the station by the Progress by its core's automated rendezvous system. So far, all of the systems on Progress and the core's receiving system on the station side of that radio beacon interface are all operating in normal fashion. The other cosmonaut on board, Alexander Gorbanov, is also up, and he's monitoring the approach of the Progress for its automated docking that is scheduled about 45 minutes from now. The International Space Station and its 7 crew members are flying 260 miles above the Earth, orbiting in an inclination 51.6 degrees to either side of the equator, moving on a track from northwest to southeast as they continue their endless journey that began almost 25 years ago with the permanent human occupancy of the station, the anniversary of that to be celebrated this coming November.
Moscow Station on Space Ground 1. Video recording is on the video server. Copy. That's great. Thank you.
You will be hearing this interpreted conversation between the Russian flight controllers and the cosmonauts on board, particularly Ovchinin and Wagner, as they are looking at a TV monitor in the service module. They'll be looking at the same views that we will be acquiring a short time from now from an external camera on the Progress resupply ship. That is the familiar cross-haired view with engineering data overlaid in that view as they will monitor the approach and alignment of the Progress and its forward docking probe in the home stretch of this rendezvous that began 2 days ago with the spacecraft's launch atop a Soyuz 2.1A booster from the Baikonur Cosmodrome. As mentioned, it was just 2 days ago when the Soyuz booster ignited its engines and lifted off from Site 31, Launch Pad 6 at the Baikonur Cosmodrome on time to begin the journey to the International Space Station. 8 minutes and 45 seconds after launch, the third or upper stage of the Soyuz booster separated from the Progress spacecraft. Seconds later, the Progress's solar arrays and navigational antennas deployed as planned, and the Progress began a pre-programmed automated rendezvous sequence to first increase its altitude in a stair-step fashion to match the altitude of the International Space Station, then began earlier today to close in on what is known as the automated rendezvous sequence, where a series of impulse burns, those are small burns using the Progress's main engines and its thrusters to fine-tune its path toward its docking position to the International Space Station. As the fly around of the station is completed a short time from now, there will be just a very, very brief period of station keeping where the Progress will put the brakes on to stop its forward approach to the station. This will enable the Russian flight controllers that you see there in this balcony view from a camera in the Russian Mission Control Center. They'll be assessing the alignment of the forward docking probe on Progress to the aft docking port on the service module before the command will be given to begin final approach. That will allow the Progress to very, very slowly, very incrementally move toward the docking position. At the time of contact and capture with the docking port at the aft end of the Russian segment of the station, we are expecting the Progress to slow to a glacial 1/10 of a meter per second before contact and capture. Today's arrival of the Progress resupply vehicle to the station is part of the ongoing chain of cargo supply missions provided to the residents on board the International Outpost, and begins a very busy month of March aboard the International Space Station with the launch of the Crew 10 crew on a SpaceX Falcon 9 rocket from Launch Pad 39A at the Kennedy Space Center, targeted for March 12th. Followed by a short period of a handover between that crew, led by Commander Ann McClain, and the departing Crew 9 crew, Commander Nick Hague, Roscosmos cosmonaut Alexander Gorbanov, and NASA astronauts Sonny Williams and Butch Wilmore, who are scheduled to come home on the SpaceX Dragon Freedom, following the arrival of their Crew 10 counterparts, who will be flying aboard the SpaceX Dragon vehicle Endurance.
At 2435, range is 6.5 kilometers, and range rate is...
The Progress is just 6,500 meters away from the International Space Station, on course and on time, about to move into the final stages of its approach for docking. Countdown clocks here in Mission Control ticking backward toward the start of the fly around of the Progress around the vicinity in the neighborhood of the International Space Station less than 18 minutes from now. Within the next few minutes, the team here in Mission Control, led by Flight Director Adi Boulos, and the Russian Flight Control team will be conferring on their communications loop, assessing the systems on board the Progress and the readiness of the International Space Station to accept its arrival a short time from now, and will give their respective go-no-go polls to make sure that all is in order for the terminal phase of the rendezvous of this uncrewed resupply vehicle. Once again, following the docking of the Progress to the International Space Station, which is again scheduled at 5:03 p.m. Central, 6:03 p.m. Eastern Time, there will be a period of leak checks at the docking interface that Ovchinin and Wagner will conduct in the Russian segment of the station to ensure that we have an airtight seal between the two vehicles. That will take about an hour and a half to complete. Then they will open the hatch to the Progress and begin unloading the highest priority cargo that is being carried on board. Again, this Progress loaded with 2.8 tons of food, fuel, and supplies for the Expedition 72 crew, broken down to 2,599 pounds of hardware, food, and experiments, 2,095 pounds of fuel, 926 pounds of water, and 110 pounds of nitrogen. Earlier today, there were tests between the Progress and the International Space Station's Russian segment, and now you're seeing a view from the external television camera on the Progress vehicle, right in the center of the crosshairs. There's your International Space Station. In the lower left-hand corner in that quadrant that you see, there are two values, 4.4 km, that's kilometers, that's the distance between Progress and the International Space Station. And at the very bottom, the minus 8.75, that is the rate of closure, just north of 8.5 meters per second. That closure rate again will drop to just 1/10 of a meter per second at the time of contact and capture. Once the docking occurs, there will be a period of a couple of minutes to allow the relative motion between the two vehicles to dampen out. At that point, the forward docking probe on the Progress will begin to retract to bring the two docking surfaces flush against one another, enabling the initiation of the closure of hooks on the Progress at the docking port at the aft end of the Zvezda Service Module to form a hard mate. Again, the International Space Station and its 7 crew members flying smoothly over the South Pacific at the moment. Its altitude 260 miles. The station about to begin a southwest to northeasterly track that will carry it over the east coast of South America a short time from now. The next Russian launch activity prescribed for the International Space Station operations will occur in early April, when NASA astronaut Johnny Kim, along with Roscosmos cosmonauts Sergei Ryzhikov and Alexei Zubrytsky, will be launched from the Baikonur Cosmodrome, the same launch pad that the Progress launched from 2 days ago. They will launch on April 8th on a two-orbit, 3-hour journey to the International Space Station aboard the Soyuz MS-27 spacecraft. That will begin the short period of handover between Soyuz crews, leading to the departure on Saturday, April 19th, U.S. time, of NASA astronaut Don Pettit and Roscosmos cosmonauts Alexei Ovchinin and Ivan Wagner, who will be returning to Earth in the early morning hours of April 20th, Kazakhstan time, for a parachute-assisted landing in the Soyuz MS-26 spacecraft. We're about 32 minutes away from the scheduled docking of the uncrewed Progress 91 cargo craft to the aft port of the Zvezda Service Module. Everything continues to go very smoothly. We are expecting shortly the next series of impulse burns using a combination of the Progress's main engines and its thrusters to fine-tune its path to the station and continue to close the rate of distance between the Progress and the International Space Station. This next series of thruster firings not only fine-tune the Progress's path to the station, but will also decrease its rate of approach, ultimately to that 1/10 of a meter per second, as we mentioned earlier, for contact and capture at the docking port.
Moscow Station on Space Ground 1 for Progress docking. Go ahead and Space Ground 1. We're seeing that
the Impulse 4 burn is underway.
Maneuver complete.
A short 16-second engine firing.
Now we're standing by for retrograde burn to complete and for the maneuver back. Yes, I confirm all. And also, we just lost the video temporarily. Yes, that's correct. Same on our end, and we're standing by for the video to come on. The video is on. Current range is 1,880 meters, and range rate is 4.1 meters per second. Copy.
And there is our first view from cameras on the International Space Station of the Progress vehicle, just about 1,800 meters away from its arrival port at the aft end of the Zvezda Service Module, closing in at a rate now of about 4 meters per second. The station and Progress shortly will be crossing the west coast of South America over the Andes Mountains, beginning a southwest to northeasterly track across eastern Argentina.
1,690 kilometers and range rate is 4.14 meters per second. Copy, and you can activate Toru.
And on board the International Space Station's service module, cosmonauts Alexei Ovchinin and Ivan Wagner are conducting another test of the Toru system, the backup rendezvous system that they operate from a joystick at a control panel inside the service module. This Toru system would only be used in the unlikely event a last-minute failure occurred of the automated Coors rendezvous system that's in control right now for all of the automated functions of the Progress resupply craft.
All right. I confirm that power is on. Command controllers are on.
We're expecting the Progress to begin its fly around of the station about 7.5 minutes from now.
Turning on BPS initial. I confirm LEDs are illuminated, and I'm pressing Toru test. I confirm that all 4 LEDs are illuminated. Up. I confirm all 4 are up. Neutral, deactivated. Left. All 4 LEDs are on. Center. Off. To the right. On. Neutral. Off. To the right. Neutral.
Again, you're hearing the Russian interpreter talking to the crew, the cosmonauts in the service module, as they run through a diagnostics test of the Toru backup rendezvous system. Again, that would only be used if there's a problem with the core's automated system, which is up and running in good shape right now. 1,200 meters separating Progress and the station, closing at a rate of just under 4 meters per second.
Illuminated, neutral, off, left, on. Outermost and central ones are on. Now neutral, off, towards me. Full test. On, off in the neutral position. And I am done with a translational hand controller test. No comments, everything's nominal.
And a good test of the Toru system in the unlikely event it would be needed. When there is a Soyuz crew approaching the station, there is no Toru requirement, because if the cores failed, the Soyuz commander seating in the center seat of the descent module of the Soyuz would take over manual control of the flying of the vehicle. In this case, without a crew on board Progress, it's up to the cosmonauts on board to act as a backup in the unlikely event the automated rendezvous system incurred a problem.
Testing acquisition and execution of commands from UBPS channel. Copy. You can proceed.
Good view from station cameras of the approaching Progress. Now just under 900 meters from the station, closing at 2.5 meters per second.
LEDs are illuminated, and I'm turning on the AGC mode.
And the view from Progress cameras as the station grows larger in the field of view.
AGC mode. Command one more time. And we see the switching of the AGC mode. We confirm. All right. I set it to the desired contrast and picture quality. All right, and I'm deactivating Rabota operation. Copy and concur.
The latest impulse burn now complete. That was a very short burn of the Progress thrusters. The next burn is coming up about a minute from now.
All right.
Here in the Space Station Flight Control Room, here in Mission Control, Flight Director Adi Boulos is polling his team of flight controllers for a go for docking.
Copy. We're standing by for 22:42:32. That's going to be the start of the fly around. Affirmative. The approximate time of the fly around start is 22:42:32. Currently, 22:39:30. Ranges.
All flight control positions here in Mission Control are go for docking. The Russian flight controllers will be relaying that information along with the assessment by their own flight control team outside of Moscow to the crew a short time from now. Alexei Ovchinin, who is joined in the service module right now by cosmonaut Ivan Wagner. Ovchinin will be assuming command of the International Space Station in less than 2 weeks from NASA astronaut Sunny Williams before she departs to return home along with Butch Wilmore, Nick Hague, and Alexander Gorbanov as all part of the Crew 9 crew. Less than 600 meters separating Progress from the station.
Range is 550 meters. Range is 1.58 meters per second.
Over the southeastern Pacific, a great view of the Progress vehicle, all of its systems in good shape, continuing its steady approach to the station, just over 500 meters separating the two craft. The rate of closure now down to about 1.5 meters per second. We're about a minute and a half away from the start of fly around.
Range is 500 meters. Range rate is 1.5 meters per second. Copy.
Just about 21 minutes away from docking of the new Progress vehicle to the International Space Station, as we have now begun the fly around. Progress, this is all automated. This fly around occurring now at a range of about 400 meters between the uncrewed resupply vehicle and the International Space Station. This will precisely align the forward docking probe on the Progress with the docking port at the aft end of the Zvezda Service Module at the rear end of the Russian segment of the station.
Rate is 1 meters per second. Closing in.
Just under 1 meter per second is the rate of closure. All of the parameters are aligning with the pre-programmed timeline and all of the data that has been loaded into the Progress's onboard computers. We are in a handover between satellites on the tracking and data relay satellite system. This brief handover will result in our reacquisition of a downlink television signal from the International Space Station momentarily.
Station, we are not receiving any video currently, so could you please report by voice? Range is 298 meters, 0.68 meters per second is range rate. And we're continuing with the fly around. Copy.
The fly around of the Progress continues in normal fashion, 278 meters separating Progress from the station. Closing at a rate of 0.6 of a meter per second. All angular rates are reported to be normal.
Range is 270 meters. 0.52 is the range rate. Closing in. Copy. Currently, we got the video back.
The station in Progress about to cross the west coast of South America.
Range is 250. Range is
about 45 degrees of fly around is left before the Progress is precisely aligned, looking right down the barrel of the docking port of the Zvezda Service Module.
Range is 230, and range rate is 0.31 meters per second. Copy.
"220 meters now separating Progress from the station, the two craft flying in tandem at 5 miles a second over the Andes Mountains. "20 degrees of fly around left for the Progress as the Core's automated rendezvous system gently steers the Progress, all automatically, to a position directly behind the service module for a period of station keeping that will begin a short time from now."
Range is 2.
That station keeping should take place at a range of about 194 meters.
Copy.
This view from station cameras looking at the Progress as it completes its fly around. You can see thruster firings very clearly in this field of view.
We see that. Station. If you want, you can adjust the quality of the video for you and work with and play with the AGC mode. All right, I'm sending BPS initial command, operation, работа, and let me adjust and work with the AGC mode.
The Progress has been commanded into a roll maneuver. This will precisely align its solar arrays into the correct orientation for final approach and docking. 181 meters separating Progress from the station. You see just above the crosshairs, that is the docking port at the aft end of the service module.
Range rate is 0.03 meters per second. We are at the axis of the docking node. Copy, we see the axis. We are getting a better pictures, and we're standing by for the station keeping.
Just about to move into a momentary period of station keeping. Progress completing its roll maneuver. The station in Progress currently flying over Buenos Aires. And station keeping has begun. This should last only a few seconds to allow the Russian flight controllers to assess the systems before they initiate final approach.
178 meters is the range, and we are in the. All right, you can send you can set flag final approach or approach-out on your own. And I'm turning on.
And the green light has been given by the Russian flight controllers for an early initiation of final approach.
44 or display 44, command.
And final approach now underway.
The command at 22, 21 00. And copy, we have deactivated the operation. Okay, operation is on, and we are standing, and we see the start of the automatic final approach. I see that the range rate is increasing, range is decreasing, and range rate is 0.79 meters per second. Range is 0.160 meters. Copy.
The Progress now just about 150 meters away from its port of call, closing at a rate of 0.8 of a meter per second.
Range is 140 meters. 0.82 meters per second is the range rate. Copy. All right, based on the image, you are basically between the sunrise and sunset. How do you see the docking node? How is the picture for you? We see the docking node. We don't see the target yet. The range is 120 meters. The range rate is 0.67 meters per second. Copy.
The space station in Progress, soon to fly directly over Sao Paulo and Rio de Janeiro. On the east coast of South America, we're about to enter an orbital sunset. There will be plenty of illumination, however, for the Progress to continue its automated approach for docking that is scheduled a short time from now.
Range is 100 meters.
The center crosshairs on this engineering overlay view from the Progress external TV camera perfectly aligned with the docking target just underneath the docking port itself on the Zvezda Service Module.
Range is 80 meters, 0.35 meters per second. We are at the axis of the docking node, and I do not see the target yet. Copy.
Approaching a distance of 70 meters to docking. Good view of the aft docking port on the Zvezda Service Module. Progress will be residing there for the next 6 months or so. Once again, once the docking occurs, there'll be a short period to enable the relative motion between the two vehicles to dampen out. The forward docking probe on Progress will retract to bring the docking surfaces flush against one another, and the initiation of the closing of hooks by the Progress and the hooks on the other side of the docking interface to form a hard mate. There'll be about 90 minutes of leak checks then, conducted by Alexei Ovchinin and Ivan Wagner, the two of the 3 Russian cosmonauts on board the station, before the hatch to the Progress will be opened later this evening, allowing Ovchinin and Wagner to begin unloading cargo.
It's a little bit hard to see the target yet, but it is already visible. Range is 0.45. Range is 45 meters, and the target is a little bit.
The Progress docking mechanism, the forward docking probe, now active. 43 meters separating the two vehicles, closing at a rate of just over 1/10 of a meter per second.
Right. And we see SSVP is ready, or docking and internal transfer system is ready. Range is 33 and 0.15 is range rate measured visually, and the electronic crosshairs and the center of the target they basically coincide. So also, just as a reminder, please do not go by electronic measurements or range measurements, so go by your measurement. All right, range is 30 meters. I am sending BPS initial command. Command has been sent. Operation Rabota is on. Command sent, and also
Continuing to hear the Russian interpretation of the Russian flight controllers talking to the crew on board the station, 30 meters separating progress from the station, once again closing at the appropriate rate of about 1/10 of a meter per second.
Okay, the next reference point is going to be 15 meters, and monitor the range and that the crosshairs are aligned. All right, visually range is 25 meters, and 0.11 meters per second is the range rate. Copy.
The space station in progress, flying from southwest to northeast, about to pass beyond the northeastern coast of South America over the South Atlantic. Everything continues to go by the book as the Progress is in the final minutes of its 2-day journey that began with its launch on Thursday from the Baikonur Cosmodrome in Kazakhstan.
Crosshairs of the target and the electronic crosshairs are mostly aligned, and the BASA air or roll angle reference values updated confirmed. Yes, copy that. We confirm that as well. Yes, I confirm that. We're beyond 15 meters in range, and range rate is 0.09 meters per second. Copy. Visual range is 12 meters. The misalignment of the crosshair is approximately 1 square at 3 o'clock. Copy. We're seeing a small misalignment of the targets.
That references to the docking target that you're looking at and the center of the crosshairs on the Progress external television camera. The Corps' automated rendezvous system should bring those two into alignment with each other momentarily.
Visual range is approximately 7 meters, and there is a small misalignment between the crosshairs of the target and the electronic crosshairs. Range rate is 0.1. Copy. Visual range is 4 meters, and range rate is 0.1. Copy.
4 meters separating the two vehicles. Coming into alignment as we stand by for contact and capture.
2 meters, and the crosshairs are basically aligned with the target center. Copy. Standing by for contact. I confirm we're standing by for contact, and the range rate is 0.11, and crosshairs are aligned. Copy.
We have contact.
Contact confirmed.
And we have capture. Docking confirmed at 5:02 p.m. Central Time, 6:02 p.m. Eastern Time, as Progress and the International Space Station flew 260 miles over the South Atlantic. Progress now in free drift, all of its thrusters disabled. A flawless 2-day journey for the Progress on its delivery run to the International Space Station.
Congratulations on the successful docking. We're standing by for the retraction to complete, and after that, you will be go for closeout operations. Copy. Thank you. Congratulations to you as well with the successful mechanical capture. We're standing by for the retraction to complete and standing by for the rest of the commands.
The forward docking probe on Progress has now begun to retract. Again, this designed to bring the two docking surfaces between Progress and the space station's Zvezda Service Module into a flush alignment for the initiation of the closing of the hooks on both sides of the docking interface. Once again, docking occurring at 5:02 p.m. Central Time, 6:02 p.m. Eastern Time, as Progress and the space station flew 260 miles over the South Atlantic. The retraction of the forward docking probe is continuing. Beginning with its launch from the Baikonur Cosmodrome on Thursday afternoon, the Progress executed all of its pre-programmed maneuvers in excellent fashion, no issues at all during the 2-day 34-orbit journey that now has resulted in Progress docking to the aft port of the Zvezda Service Module and the start of the delivery and unloading of the cargo, some 2.8 tons of food, fuel, and supplies for the Expedition 72 crew.
Moscow Station on Space Ground 1. For TV system, can I execute steps 11 and 12, deactivation of the TV server, video server, and MPEG viewer, deactivation of recording. Ivan, stand by 1, please. Okay.
Now, with the alignment having been completed and the forward docking probe fully retracted, we now see data that indicates the initiation of the closing of the hooks on Progress to form a hard mate.
Station Moscow on Spaceground 1 for Ivan. Go ahead.
Можно отключать.
Your go to stop the video recording. Copy. Steps 11 and 12 are in work.
Приступай.
Copy your go.
This is Mission Control Houston. The Progress hooks now confirmed to be closed. We have a hard mate now between the uncrewed Progress 91 cargo ship and the International Space Station, concluding its 2-day journey to deliver 2.8 tons of food, fuel, and supplies to the Expedition 72 crew. So with that, we'll wrap up our coverage. Once again, the docking occurred at 5:02 p.m. Central Time, 6:02 p.m. Eastern Time over the South Atlantic. All of that food, fuel, and supplies now will be unloaded by the cosmonauts on board the International Space Station as work continues aboard the station continuously by the residents of the orbital outpost.
Go ahead and switch to ground 1.
You can follow all of the activities of the International Space Station on our website at www.nasa.gov. With that, we'll wrap up our coverage. Progress safely in port at the International Space Station. Have a good weekend. Thanks for listening. This is Mission Control Houston.